Hi students. In the last class we have learned how to solve the exercise problems. So that means how to find the rational numbers between two rational numbers, and not only that we have found how to find the simplest form of rational numbers. So today also remaining few of the problems are there in the exercise 9.1. We will finish now today. Right. So take your textbooks and see page number 183. Saint 1. Fill in the boxes with the correct symbol out of, greater than, less than and equal. So these symbols are comparing symbols. Now we have to compare these symbols. Okay, compare the rational numbers using the symbols. Is it clear? Right. So see here, first one. So 81C, minus 5 by 7, 2 by 3. Minus 5 by 7, 2 by 3. So tell me here, which rational number is greater or which rational number is lesser? Okay. So look here. So whenever we want to compare the two rational numbers, first we have to find the LCM. So what is the LCM of 7 and 3? 7 and 3 is 21. Okay. Now find the equivalent ratio of minus rational number of minus 5 by 7. So you have to show the denominator as 21. So that means you have to multiply the denominator and numerator by 3. Then only you will get 21 as the denominator. So minus 5 into 3 is minus 15. Right. 2 by 3. Okay. So 2 by 3. So here also numerator and denominator multiplied by 7. So what is that? 2 into 7, 14 by 21. Now the two rational numbers having the same denominator, that is minus 15 by 21, 14 by 21. So look here, it is a negative rational number and it is positive rational number. So always remember, negative rational numbers are always less than the positive rational number. So here only you can give directly. So but you have to follow the procedure. Okay, no? Right. So now tell me which one is lesser? Minus 15 by 21. Okay. So negative rational numbers are less than the positive rational number. So minus 15 by 21 means what is the rational number of what is equivalent rational number here? Minus 5 by 7. That means minus 5 by 7 is less than 2 by 3. Right. See, next third one, minus 7 by 8 and 14 by minus 16. So here also we have to find the, what you have to find? Yes, first to find the LCM. So see here, we will simplify this one easily. So no need to find here first. So it is minus 7 by 8 and we will write the 14 by minus 16. Okay. So if you simplify 2 sevens and 2 eights, then minus 7 by 8 and 7 by 8 minus 8. So are these rational numbers are equal or lesser or greater? Yes, these two rational numbers are equal. Why? Because here the numerator having the negative sign, here denominator having the negative sign. So any rational number having either numerator is negative or denominator, so then we can say that the rational number is a negative rational number. Okay. So then the two rational numbers are equal here. Two rational numbers are equal. So like that. So remaining 4, 5, 6 and 7. So these problems you have to do yourself. The exercise 9.1. So in the 8th question, 4, 5, 6 and 7 problems you have to do yourself. Right. Next turn your papers. So like the question, which is greater in each of the following? So which one is greater? So here also we have to use less than, greater than or equal. So greater means how to show this one greater. So if different rational numbers given, so at that time we have to converting into like fractions. Okay. So here different fractions given in the 9th question. So first one 2 by 3 and 5 by 2. Okay. So every fraction is a rational number. So here 2 by 3 and 5 by 2. Which one is greater? So these rational numbers we have to converting into like. So like fractions. Okay, what is the LCM of 3 and 2 here? The LCM of 3 and 2 is 6. Okay, na? Right. So find the equivalent rational numbers of 2 by 3. So that means you have to multiply the numerator and the denominator by the 2. So that is 4 by 6. Next to 5 by 2. So 5 by 2. Here also you have to multiply the numerator and denominator by the 3. Then you will get 15 by 6. Now tell me 4 by 6 and 15 by 6. Which one is greater? 15 by 6 is greater than 4 by 6. So therefore 2 by 3 is less than 5 by 2. Is it clear? Right. See here minus 5 by 6 minus 4 by 3. So which one is greater? We have to find here. So here also see the denominators are different. Okay. So at that time what we have to find? So we have to convert them into like fractions. So we have to find the LCM of two fractions. Here the fractions of the denominators are 6 and 3. So what is the LCM of 6 and 3 is 6. Okay, so otherwise you have to find. So that is 3 twos, 6, 3 ones. Again 2 ones, 1. 3 into 2 is equal to 6. Okay, right. Now, so next one is we have to find the equivalent rational numbers. So we have to show the denominator as 6 of both rational numbers. So already we have the denominator as 6. So here no need to write. So if you want you can write here into 1 by the numerator and the denominator. Then only we will get minus 5 by 6. So like that minus 4 by 3. So here we have to find the equivalent rational number. So we have to multiply the numerator and the denominator by the same number, that is 2. Okay, so minus 4 into 2 is equal to minus 8 by 6. Now minus 5 by 6 minus 8 by 6. So observe minus 5 by 6 minus 8 by 6, which one is greater? Minus 5 by 6 is greater. Okay, so here see it has a negative sign. Okay, if you ignore the signs 8 is greater. Okay, so if you consider here negative signs of minus 5 and minus 8, minus 5 by 6 value is greater than the minus 8 by 6. Right. See third one, minus 3 by 4 minus 2 minus 3. Minus 3 by 4 2 by minus 3. So which rational number is greater? So these are also two negative rational numbers. So here also we have to find the LCM of 4 and 3. What is the LCM of 4 and 3? Is 12. Okay. So here minus 3 by 4, we have to find the equivalent rational numbers. So that means we have to show the two rational numbers having the same denominator. So that is 12. So you have to multiply the numerator and the denominator by the 3 only. Then only you will get the denominator as 12. So minus 3 into 3 is minus 9. 4 3 is 12. Next to 2 by minus 3. So here also multiply the numerator and denominator by the 4. 2 4s 12, that is minus 8 by 12. Now minus 9 by 12, 8 by minus 12. Tell me which rational number is greater? Which rational number here? Minus 9 or minus 8? Minus 8 is greater than. Okay, so here 8 having positive sign and 12 is having a negative. Whatever it may be, in the rational number of either numerator and denominator having a negative sign, we can consider that one as a negative rational number. So here you can, if you convert this one into standard form, the negative sign will come to minus 8. So after you compare minus 8 and minus 9, which one is greater? Minus 8 is greater. So that means here minus 9 by 12 is less than 8 by minus 12. So therefore minus 3 by 4 is less than 2 by minus 3. Is it clear? Right. Next, fourth one you have to do. So which one is greater? So 1 minus 1 by 4 and 1 by 4. Which one is greater? So that one you have to find. And so last one I am explaining it now. Fifth one, that is minus 3 2 by 7 minus 3 4 by 5. Okay. Students, next one minus 3 2 by 7 minus 3 4 by 5. So these are which type of fractions? Mixed fractions. Okay, we have to convert them into improper fraction. Then only we can say that which fraction is greater. Right. So you know very well about how to convert a mixed fraction to improper. Tell me minus 3 2 by 7. Okay. So here see how to write the mixed fraction to improper fraction. Whole part, that is 3 into denominator, okay, plus numerator, that is 2 by denominator, that is 7. Here minus is there, so we have to mention minus. Next, 3 sevens are 21 plus 2 by 7. Next, 21 plus 2, 23 by 7, that is minus 23 by 7. This is the improper fraction of minus 3 2 by 7. Next, minus 3 4 by 5. So here also you write minus 3 into 5 plus 4 by 5. That means 3 5s are 15 plus 4 by 5. It is equal to 15 plus 4 is 19 minus 19 by 5. Now, so we got here the two improper fractions are minus 23 by 7 and minus 19 by 5. Tell me, these two denominators having same? No, the two rational numbers or two fractions having different denominators. So that's why we have to convert them into like fractions. Then what is the LCM of 7 and 5? 7 and 5 is 35. That we have to show the two fractions of denominator is 35. How to write? The equivalent rational numbers of minus 23 by 7. So you have to multiply the numerator and denominator by the 5. Okay. 23 fives. How much? What is the value? 23 into 5. 5 3s are 15. 5 2s 10 plus 1 11. That is 115 by 7 5s 35. Next, minus 19 by 5. So minus 19 by 5. Multiply the numerator and denominator by the 7. Okay. So 19 sevens. 19 into 7. How much? 133. So minus 133 by 135. Now minus 115 by 35 and minus 133 by 35. the two rational numbers having the same denominator, then we can compare only the numerators. Minus 115, 113, minus 113. Which one is greater? Minus 115 is greater. So this fraction is, therefore minus 3, 2 by 7 is greater than minus 3, 4 by 5. So like this we have to compare which one is greater. Is it clear, children? Right. Next to take your textbooks. Last one in this exercise, 10th problem. Read the question once. Write the following rational numbers in ascending order. Ascending order means smaller to bigger. Okay, na? Descending means bigger number to smaller number. Here we have to write the ascending order means smaller to big rational numbers. So which rational numbers are given here? Minus 3 by 5, minus 2 by 5, minus 1 by 5. Okay. So how to write these rational numbers? Before writing the ascending order, first see these all rational numbers having the same denominator. Yes, so these all are having the same denominator. Okay, so then it is easy to write the ascending order. So you know very well about which one is smaller. So minus 3 now, minus 2 now, minus 1 now. Which one is greater here? Minus 3 by 5. Okay. So this minus 3 is less than minus 2 by 5 is less than minus 1 by 5. It is very easy now. So that means minus 1 by 5 is greater than minus 2 by 5. Minus 2 by 5 is greater than minus 3 by 5. Right. Next, second one, see, minus 1 by 3, minus 2 by 9, minus 4 by 3. Okay, look here. So these fractions are, so all are different. Okay, so these rational numbers having the different denominators. Okay, na? So at that time, what you have to find? The LCM. Very good. The LCM of 3, 9 and 3 is, what is that? 9 or 3? Okay, you can find. So 3 ones, 3 threes, 3 ones. Again 3 ones, 1, 1. That is 3 into 3 is equal to 9. Okay, these are the factors of 9. So the highest value is 9. The LCM of 3, 9 and 3 is 9. Okay. Now we have to write the minus 1 by 3 of equivalent rational number. So that means you have to multiply the numerator and denominator by 3. That is 1 into 3 minus 3 by 3 3s are 9. We have to show all the rational numbers having the same denominator, that is 9. Next rational number, that is minus 2 by 9. Minus 2 by 9 already having the denominator 9. Then you just multiply by 1 the numerator and the denominator. You will get minus 2 by 9. Similarly, minus 4 by 3. So what is the equivalent rational number? Here minus 4 by 3. Multiply the numerator and denominator by the 3. We will get minus 4 into 3. 4 3s are 12 by 3 3s are 9. Now write all rational numbers. Minus 3 by 9, minus 2 by 9, minus 12 by 9. Okay. So now all the rational numbers having the same denominator, we have to consider only the numerator. Okay. So which one is greater and which one is smaller? So here we have to write the ascending order. Okay. The ascending order is, ascending order means smaller to bigger. Which one is smaller here? Which rational number is smaller? Yes, minus 12 by 9 is smaller than, next minus 3 by 9 is smaller than minus 2 by 9. So that means, so what is that? Original minus 4 by 3 is less than minus 1 by 3 less than minus 2 by 9. This is the ascending order. Is it clear, children? Right. So like that, one more rational numbers are there. Third one, minus 3 by 7, minus 3 by 2, minus 3 by 4. This one I am giving to you homework. Then the 10th one, in the 10th question, third one is homework. Okay, right. Students, after all, we have learned so how to write the rational numbers in the ascending order. Okay, so equivalent rational numbers, how to compare the rational numbers, how many rational numbers between two rational numbers. We have learned in this exercise 9.1. Okay.
Welcome to the lesson on Introduction to Rational Numbers. At the end of this lesson, you will be able to define rational numbers. You will also be able to identify positive and negative rational numbers, obtain equivalent rational numbers, and express rational numbers in their standard form. In addition, you will be able to represent rational numbers on the number line. High up in the sky, above the clouds, lives Mr. Number Maker. Mr. Number Maker makes all the numbers for us. This is Naughty Yank, Mr. Number Maker's grandson. He loves to play with Grandpa's numbers. He's always up to some mischief. Wonder what he's doing now.
Now, what is all this racket about, Unc? What are these numbers? Let me see. All of them have a numerator and a denominator. Can we call these numbers fractions? Let's recall our understanding of fractions. Fractions are a collection of numbers of the form a divided by b, where a and b are whole numbers and b is not equal to 0. But some of these numbers are made up of negative integers. In the first number, the numerator is a negative integer. In the second, the denominator is a negative integer. While in the third number, both the numerator and the denominator are negative integers. By definition, these numbers cannot be called fractions. Seems like Unc has created a new group of numbers. These numbers are called rational numbers. A rational number is a number that can be written in the form p divided by q, where p and q are integers and q is not equal to 0. Let's check what all numbers Unc had put into the number machine. Looks like Unc had put positive and negative integers, fractions, 0, and decimal numbers as well. All the numbers changed to the numerator divided by denominator form. Just like fractions, all whole numbers, integers, and decimal numbers can be written in the numerator-denominator form. these numbers are also rational numbers. Like positive and negative integers, rational numbers are also positive and negative. Here are some rational numbers. Let us look at each one of them and see if it is positive or negative. Consider the number 2 divided by 5. Here, both the numerator and the denominator are positive integers. Here are some more examples of positive rational numbers. All such rational numbers, where both the numerator and the denominator are positive integers, are called positive rational numbers. Now consider these two numbers, -2 divided by 5 and 2 divided by -5. If either the numerator or the denominator of a rational number is a negative integer, then the rational number is called a negative rational number. Here are some more examples of negative rational numbers. Now we come to the number -2 divided by -5. In this number, both the numerator and the denominator are negative integers. If we multiply both the numerator and the denominator by -1, we see that the resulting number is 2 divided by 5. It is a positive rational number. So, if both numerator and denominator are negative integers, then the rational number is positive. Here are a few more examples. Let me restate the rules for you once again. A rational number is positive if both its numerator and denominator are either positive or negative integers. A rational number is negative if either its numerator or its denominator is a negative integer. The number 0 can be written as 0 divided by 1 or 0 divided by -1. In either case, its value remains 0. Thus, the rational number 0 is neither negative nor positive. Consider two integers, 8 and -6. If we multiply both integers by 2, we get two new numbers. Now, let's make a rational number -6 divided by 8 with these two integers. If we multiply both the numerator and the denominator of this rational number by a positive integer 2, we get another rational number -12 divided by 16. Next, we'll multiply the numerator and the denominator of the first rational number -6 divided by 8 by a negative integer -3. We get another rational number 18 divided by -24. All three rational numbers are equal. Similarly, we can divide the numerator and the denominator of a rational number with the same integer to get another rational number that is equal to the given number. Dividing 18 and -24 by 6, we get another rational number 3 divided by -4. This rational number is equal to the previous three rational numbers. Such rational numbers are said to be equivalent to each other. By multiplying or dividing both the numerator and the denominator of a rational number by a non-zero integer, another rational number is obtained, which is the equivalent form of the given rational number. In this section on equivalent rational numbers, we saw that all the numbers shown here actually represent the same rational number. But what is that rational number? To find what rational number all these numbers represent, we have to find an equivalent rational number whose numerator and denominator do not have any common factor other than 1. Here, -6 and 8 have common factors 1 and 2. -12 and 16 have common factors 1, 2 and 4. and 18 divided by minus 24 have common factors 1, 2, 3 and 6. However, 3 and minus 4 have only 1 as their common factor. The number 3 divided by minus 4 seems to be the number we are looking for. However, my rule book says that the number we are looking for cannot have a minus sign in the denominator. Getting rid of the minus sign in the denominator is easy. We just need to multiply the numerator and denominator by minus 1. The number minus 3 by 4 that we have now meets all the conditions. Here we have a rational number whose numerator and denominator have no common factors other than 1 and whose denominator is a positive integer. This form of a rational number is called its standard form. By saying that minus 3 divided by 4 is the standard form for all these equivalent rational numbers, we mean that all these numbers can be reduced to minus 3 divided by 4. Let's see how. To reduce a rational number to its standard form, we divide its numerator and denominator by their highest common factor, or HCF for short. Consider the number minus 6 divided by 8. The HCF of minus 6 and 8 is 2. Dividing the numerator and the denominator by 2, we get the number in its standard form. Now, consider the number minus 12 divided by 16. The highest common factor of minus 12 and 16 is 4. Dividing the numerator and the denominator by 4, we get the number in its standard form. Now, we come to the number 18 divided by minus 24. The HCF of 18 and minus 24 is 6. Here, note that the denominator is a negative integer, so we divide the numerator and the denominator by minus 6 in place of 6 to get the number in its standard form. Look what I have here. The number line, it's my favorite tool. I can use it to show all the numbers in the world. Right in the middle of the number line is 0. Now watch. Grow, grow, grow. The positive integers get marked to the right from 0. The negative integers get marked to the left from 0. Note that 1 is at the same distance to the right of 0 as minus 1 is to the left of 0. Here are some rational numbers. We can also represent rational numbers on the number line. Just like positive integers, positive rational numbers are also represented to the right of 0. Negative rational numbers, like negative integers, are represented to the left of 0. Now, 1 divided by 3 is 1/3 the distance from 0 to 1. So we divide the distance from 0 to 1 into 3 equal parts. The first mark from 0 represents the rational number 1 divided by 3. Just as the distance of 1 and minus 1 is the same from 0, the distance of 1 divided by 3 and minus 1 divided by 3 will also be the same from 0. So, we divide the distance from 0 to minus 1 in 3 equal parts. The first mark from 0 represents the rational number minus 1 divided by 3. Now, 2 divided by 3 is the 2/3 of the distance from 0 to 1. So, the second mark from 0 between 0 and 1 represents the rational number 2 divided by 3. The distance of 2 divided by 3 and minus 2 divided by 3 is the same from 0. So, the second mark from 0 between 0 and minus 1 represents the rational number minus 2 divided by 3. The rational number 3 divided by 3 actually just represents the number 1. Thus, it occupies the same place as the positive integer 1 on the number line. Similarly, the rational number minus 3 divided by 3 actually represents the number minus 1. Thus, it occupies the same place as the negative integer minus 1 on the number line. Similarly, you can mark more rational numbers on the number line. Draw your own number line and practice. I must go now and find my naughty grandson who started all this.
This brings us to the end of the lesson on Introduction to Rational Numbers. In this lesson, you learned to define rational numbers. You also learned to identify positive and negative rational numbers, obtain equivalent rational numbers, and express rational numbers in their standard form. In addition, you also learned to represent rational numbers on the number line. Represent the number minus 3 divided by 5 on the number line. Draw a straight line and mark its center as 0. As the given rational number is negative, it will lie to the left of 0 on the number line. Mark a point to the left of 0 on the number line. This point P represents the point minus 5 divided by 5, which is equal to minus 1. Mark 4 points at equal distances between 0 and P to divide the distance into 5 equal parts. Point Q on the number line represents the number minus 3 divided by 5.